Hello, class. Today, I just want to try and solve some examples on how we utilize natural log and its properties to solve simple problems. So, let's look at the very first question. The very first question is ln x is equal to 2.7. So, this is my thought process. Anytime I have an x in a natural log, I'm inclined to convert it back into an exponential form. If I can do that, then it gives me some chance to solve the problem because the natural log has a base. It's got an exponent, which is what the output is supposed to give me, and then it's got an argument. So if you rearrange things back in exponential form, we're going to get e. Remember that's got an invisible base, which is e 2.7 is equal to what? Is equal to x. So that's what I get for solving that. And you can check it and see. If you have ln e to the 2.7, to what power should you raise that special e to give you 2.7? It has to be what? It has to be 2.7. So that checks out. Let's look at 3b. So 3b is ln x plus 1 is equal to 1.86. Again, the x that I'm trying to find is part of an ln. So for me to get to that x, I need to try and convert this into an exponential form. And in this case, what I get is e to the 1.86 is equal to x plus 1. So I end up with e to the 1.86 minus 1 is equal to x. Let's look at 3c. In 3c, it feels like you need to use a log, but you don't. It's just trying to see if you can still remember your logarithmic expression. So I have x is equal to e to the 9.8 divided by e to the 7.6. Well, when you have same base, rules of exponent tells us that we need to subtract the power. So this gives me e to the 9.8 minus 7.6, which gives me e to the 2.2 equal to x. So that is the value for x. Let's look at 3D. So 3D, things are a little bit different over here. We are no longer dealing with exponential logarithmic function, but exponential functions. So the problem with this is the variable that I'm trying to find is a power. And the only way that we can resolve that is if we change it into a logarithmic form. As long as we can do that, we should be able to find that because a log returns back to us an exponent. So in this case, I'm going to have log. So here the base. So remember that the exponent form, this is the base. That is the exponent. And then this is the argument. Okay, so I'm going to get log e of the argument 6.27. And that's equal to what? That's equal to x. And we found that's just x. But remember that log e is another cool name to represent ln. So this is going to be ln 6.27 is equal to x. You can equally leave it as log e, but we prefer to leave it as ln. It's much cooler. 3e. I got 4.12 is equal to e to the negative 2x. And again, I'm going to try and switch things back into logs because what I'm trying to find is a power, it's an exponent, and we know that a log returns back to us an exponent, and that's going to actually help us solve for that x. So I get log e of 4.12 is equal to negative 2x. And I'm going to try and rewrite log e as ln. So this is the same as ln 4.12 is equal to negative 2x. Now I can clearly solve for x. X is going to be 1/2, negative 1/2. ln 4.12 is equal to x. So there you have it. All right, so it's just a matter of manipulating between switching to exponential when you have a log expression, and when you have a log expression, switching it to exponential form to see if that's going to help you resolve that x that you're trying to find. I hope this is helpful as you work through your problems on homework or the worksheets.